developer, a renowned author, and a passionate speaker. When he's talking about software development, we should probably be listening. At least I should. So without any further ado, Venkat, we're all yours. Enjoy.
Thank you very much. Thank you. Thank you. It's immense pleasure to be here. It's almost overwhelming to be standing here and talking about it. The things that's being done here. And I just realized they are talking about particle physics, and I'm here to tell you that I am that particle. I am that little thing, that piece of dust compared to what's going on. That's amazing. Thanks, Stefan, for having me here. I really appreciate it. Thanks for Hardy, because my computer broke today, so it's crashed. So I'm going to do the demo from Hardy's machine. Hopefully, I know how to use this machine, but I'll try my best. It's a great pleasure to be here. I want to talk about reactive programming. So one of the things that I find as challenges when I look at new technologies, I often ask the question, where did it come from? There's always got to be a context. So I was really struggling to understand what reactive programming is. And then I'll just share with you some of my learnings and how I look at it. The theories and concepts are extremely important, absolutely no doubt about it. But I also want to really relate it to what we can do on a daily basis. How can we put this to use? And that's what I want to really focus on today. So what is really reactive programming? Well, I come to realize that we work in a field where every 10 years or so, we'll give a new name for what we already do and get really excited about it. And so this time around, it's called reactive programming. And that's a great thing, because then we can party, have fun time. But this has been around for a very long time. This is really nothing new at all. In a way, if you really think about it, extreme programming was nothing new. And yet what was new about it was it brought together about 12 different practices that were extremely important for us to focus on and do. In a similar way, reactive programming brings 4 different practices together. But obviously the question is, why and why now? Why should we change what we do, or at least rethink about what we do? And the reason is, I'm almost in tears when I say this, but I remember those beautiful days when I used to wake up in the morning, turn on the coffee pot, and as my coffee pot is brewing coffee, I would hear my modem connect and reconnect and disconnect and reconnect. And then I would call my friends and ask them, what's your baud rate today? Those days are long gone. Every one of us is walking around with multiple devices connected to the internet all the time. The biggest geek I personally know is my son. I patted him one day, and several devices fell off him. I don't even know how many he is carrying. I couldn't confiscate enough of them soon enough. And we are talking about these devices. The second thing is, if you really look back about 10 years ago, what companies really did was they made their employees available to us, the users, and they made software available to their employees. Well, employees using software, there's a special name for them. They're called captive users, meaning nobody cares what they think about. But on the other hand, we, the real-world users, have a greater demand on applications. No matter how much what size of your company is, I can bet you have more customers than employees. So the demand on the application is a lot more today. The third important reason is that we are interacting with applications so differently today than we did 15, 20 years ago. I mean, we're talking about wearable devices. And when I talk about wearable devices, forget watches and devices like that. I'm talking about earrings, nose rings, and tongue rings, all of them internet-enabled, constantly communicating. And the days when doctors can have devices on us, where the devices are constantly monitoring our health, and the doctors get to know about our health condition even before we realize that something could be wrong, is not very far away. Well, all this is really leading to big data. And when I say big data, I'm really talking about high frequency, high volume of interaction, and how do we go about dealing with it? Well, this is where reactive programming really starts about. And it really is about having an architecture that focuses on 4 key components. The first is message-driven architecture. We really want to be able to use messages to communicate. I'm going to say using a distributed transaction on a centralized database is so 20th century. It makes no sense to do it. So we definitely want to use the communication that we can use by using messages. Well, scalability is extremely important. I was talking to a client recently, and I asked them, how many users use your application on a given day? And they said, oh, about 200 users use our application on a given day. I kind of laughed and said, 200 users? Well, you guys are a billion-dollar company. How come you have only that many users? And they said, well, you asked on a given day. Well, generally people use the computer only for maintenance, but on 2 days in a month, about 50 million people use it. Well, and those 2 days, the system better be really producing good throughput, and all the transactions happen on those 2 days. How do you scale for something like that? And I'm going to say that maintaining your own infrastructure and maintaining staff to maintain those infrastructure doesn't really make sense anymore in 2017. The cloud computing has shown us how we can deploy machines on the fly. You can configure it to start services when the demand goes up, whether it's time-based or load-based, and then when the demand goes down, those computers can go away virtually, and as a result, we pay as we go. And of course, we have learned how to really leverage cloud computing really well, and that's what they talk about as elasticity, and that's something they really recommend doing. The next thing to think about is responsiveness. Now, why is responsiveness so important? We don't live in the world where we're going to be patient. We are all living in a world of instant gratification. If an application doesn't respond right away, you have moved on to work with something else. You're not going to sit there and wait for those applications anymore. Responsiveness is extremely important. Imagine you walk into a store on a Sunday afternoon, and then you notice the clerk is busy helping somebody. And what are you going to do? You're going to look around for a few minutes, look at the wall, look at the ceiling, look at the floor, and then you're going to quietly leave. Why did you do that? Because there was no responsiveness, and then you're kind of feeling like there's not the place where you want to be. Well, on the other hand, you come into the store, and the minute you walk in, the clerk who is busy with somebody makes an eye contact and says, I'll be with you shortly, and then goes back to help the other customer. What did you do? You probably waited for a good 15 minutes. Why? Because you felt important, even though you know you're not. And the point really is, that's one of the key things is responsiveness. Imagine the very first day you discovered infinite scroll. What an idea. You have been using the site for a while, but that day you came in and it snapped back with a response. You're like, wow, it's fast today. Wonder if I have a better internet connection. And you scroll down, and your brain just caught the fact there is nothing in the bottom. And before you could react to it, well, something filled up the space. And then you scroll down, and it's like, wow, as you're scrolling, more data keeps filling in. Well, that's a great idea, because they did not work so hard to get all the data. They got you enough for you to look at, and while you're looking at it, they go back and get more things. That can make the systems really responsive. That's a great idea. But what about resilience? That's extremely important too. The worst kind of applications are the ones that fail in unpredictable manner. I remember, I won't tell you what country this is, but I was filling the visa application. I'm on the 15th page. The worst question they could ever ask me is, list all the countries you have visited. I'm like, are you kidding me? So I enter all this data, and my heart is pounding because I'm the last page. I'm saying, please, please, please. And I click the button, and the whole damn thing closes. And you're going to start over again, right? And that's really a poor application to be working with. And you want to save the state. You want to be graceful to the users. That's very critical. Well, you want the applications to be really resilient. That's very critical. Well, I was speaking. I've been teaching at the university for about nearly close to 30 years now. But I was speaking in a conference last year. And a gentleman came to me and he said, hey, Venkat, I took your distributed object computing course back in 1998. I said, oh, I remember teaching that course in 1998. He said, I got a story to tell you about it. I said, I love stories. Tell me what story you got. He said, I was in your class, and it was a demo day, and we were doing a demo of the final project. And when I was doing the demo, you quietly walked up to my machine, disconnected the internet cable, went back and sit down and said, continue. And my application crashed, and I failed the project. I said, I'm really sorry to hear it. I don't like hearing stories of failures like this. I'm really sorry that I failed you in the project. He said, no, I wanted to really come and tell you this story because you helped me a lot. I said, how could I help you by failing you? He said, because that's the last day I ever wrote code like that. He said, from then on, when I write code, I always deal with errors. I always deal with exception. And he went on to say, these days when I code at my work, in my cubicle in front of me, I have a picture of evil Venkat, and I look at that picture every day when I code. I don't think we want to have a picture of evil Venkat in front of us to code it, but the point really is that we do want to really plan for resilience. That's extremely important. So these are the 4 things that it really brings together, is to leverage elasticity to deploy applications, to use message-driven architecture, to be able to build applications that are responsive, and to make them really resilient is extremely important. But if you really think about it, what does this all really mean to us? Well, let's step back for a minute and rethink about what we've been doing for, good about 20 plus years. And we can pretty much summarize what we have been doing to maybe developing CRUD applications. Almost every one of us spends time developing CRUD applications. You read data, you delete data, you update data, but then you realize, would the entire world be full of CRUD applications? There's got to be applications where it doesn't fit into CRUD after all. And suddenly we realize, yes, there are applications that don't quite fit into CRUD. For example, I want to listen to, let's say, a Twitter stream. You want to know what people are tweeting. I mean, that's the best way to waste time, isn't it? And then you can just start listening to the Twitter feed, and then if there's something of interest to your product or your company, you can do some processing about it, otherwise you can just ignore it. In a similar way, you could be looking at stock data coming through, and you're not interested in all the stock data, but a particular data in a particular range, and when that Google stock price hits the price you really are looking for, maybe that's when you want to do the trade. Until then, you want to just slip it by. Or today we heard about how so much volume of data is being collected here in the detectors, but you're not obviously interested in all that data, so you're filtering out and selecting only data that you care about. These are all really not CRUD applications. These are applications where you have some middle agent that's interested in looking at the stream of data coming in and can take action based on what they need. And then all of a sudden we say, well, okay, maybe we should rethink about the way we develop applications. Now, what do we do as programmers when we rethink about things? We start coding, and the minute we start coding, we realize, well, this is really painful to code all of this. And at that point, you have 2 options. When things become painful, you can give it to somebody else to code it. Well, that's one way to solve the problem. But usually that somebody else is us, the programmers, for 2 reasons. Because we are the programmers, and second, why would you want to give the real fun stuff to others anyways, right? Well, the second way to really get this done, to be productive about it, is to raise the level of abstraction, and that's what we are talking about here, is a level of abstraction that's been risen enough so we can actually do reasonably well with this. But in a way, if you really think about it, well, I mentioned that this is nothing new, this has been around for a long time. You couldn't have been a programmer in the 80s and not heard about what are called data flow computers and data flow computing. Well, data flow computing is where you really have components, or you can have expressions that are ready to be fired or computed as soon as the data that they need becomes available. Well, data flow computing offers true parallelism. And the reason is you're not going from instruction to instruction to instruction. Your instructions are kind of floating around, and the minute something is ready for the instruction, it's ready to fire. If I tell you data flow computing is awesome, we can do it, you're going to say, old man, sit down, we're not interested. But if I tell you, well, we could be using Amazon Lambdas, you're like, ooh, that's awesome, because we give a name called serverless computing, and this is really awesome. What is that? Data flow, right? Because you got processes that are ready to fire, you don't have affinity to a server, but they can execute as soon as data becomes available. Well, the concepts are being recycled, but what it really is that it's really a commercialization and more so adoption of technologies that we once were able to talk about, but we are able to actually realize it. In fact, I would want to emphasize this because when I was a young developer, it was frustrating for me because I would read books And I would read all these wonderful ideas, and then I would look through the window and say, I really wish I can do these things rather than reading about it. And now I feel like a kid all over again because I can do everything I read decades ago because that's really viable and available to us with the way the software industry, but not only that, but the hardware industry has changed as well. These are within reach for any common person to play with. That's phenomenal. So I want to really get into the code level and see what this really means. And for this purpose, I'm going to ask for help from one person here who has a smartphone and wants to help me. Who wants to be the volunteer? Don't be shy. Who wants to help me? Yes, sir. What's your name?
I'm Pavel.
Sorry, say something for me.
I'm Pavel.
Babel?
Pavel.
Pavel. Pavel.
Yes.
Nice to meet you, Pavel. You can sit down while you help. Oh, in the chair. Okay, you have the chair there. Okay, good. All right. I want to make sure there is a chair. All right. Are you ready? All right, I want you to, your smartphone is ready? Yes. And I want you to tell me the following. The stock price for Google and for Amazon and for, let's say, Intel. So I want the price for all these three, please.
Say again?
I want the stock price for all of those three.
Stock price?
Yes. Are you done yet? Pavel, we're counting on you. Who here thinks that Pavel is very slow? Everybody thinks you are slow, Pavel. Are you really done?
I will fly.
He will fly. He's giving excuses.
I'm offline.
You are offline?
Yes.
How disappointing. Are you still trying?
Yes.
Okay. Well, thank you, Pavel. You really explained how the World Wide Web works. Why don't we give him a hand? That was awesome. So, thank you. So what did he do? He very beautifully explained how the World Wide Web works today, right? What do you do to the World Wide Web? You make a request. What does the web do? Oh, thanks for calling, and goes down to work. And what does the user do? Are you done yet? And the user says, well, this site is not responding. Let me help, and clicks the refresh button. So what does that do? It creates one more thread on the server. It's like me constantly interrupting him. Was I helping him asking more questions? No. Now he has 3 or 4 threads running. One to see what's not working. What does Venkat say? What does everybody else say? And he's completely distracted, right? In the meantime, I was impatient. I said, never mind, don't do this anymore. And he never really saw me do that. Why? Because he was so busy doing the work like the web applications do. And eventually the web application finishes and says, the result, where did the user go? And the user has long gone before, right? Well, I'll tell you, somebody like Pavel did something absolutely phenomenal in a presentation I was giving earlier. I've never seen anyone do what this guy did, either before or after. So what I did was, I gave him the exact same question. I said, give me the stock price for these 3 stock values. Well, the guy immediately said, oh, okay, and recruited 3 people around him. And he said, you find the price for Google, you find the price for Amazon, you find the price for Intel. And by doing so, he immediately demonstrated not only can a machine suck, a cluster of machines can suck too, collectively together. And I could have never done this better. So the point really is, we've been getting this totally wrong. We cannot be just taking somebody's request and go nose down to process it, because that is just simply not efficient at all in what we do. So what are we really trying to get to? I'm going to say efficiency is achieved not by doing things faster. It is actually achieved by eliminating things we shouldn't be doing in the first place. If Pavel says, why do you care about all these prices now? Can I give you one of these prices? I can get back to you later on, for example, right? That's a way to say, I'm going to give you some, and if you don't want any more, I'm not going to do any more. Let me rephrase what I said. What I'm saying is, it pays to be lazy, both in life and in programming, because laziness means efficiency. And that's one of the key components to think about, is not to be eager and agitated and do everything when the instant it's given. Just take it easy a little bit. And then if it's important, we'll come back and do it, not otherwise, right? So how do we get to that point? This is where observable comes in. So what's observable? Observable is a data source. It's a data stream. And an observable can start sending a stream of data, and we can process the stream of data as the data arrives towards us. Well, JavaScript has a concept of promises as well. And the main difference is a promise is a single transport of data. An observable is a continuous stream of data. I'm a huge fan of public radio. I have to listen to public radio every morning. And when I turn on the radio, I listen to the program. When I turn it off, well, they still transmit the program. It's just that I don't care to listen anymore, and they don't care that I don't listen anymore. So it plays even. So the point really is that I can turn in and listen to it, but it's a stream that keeps flowing towards me. And that's what an observable is. But wait a minute, but how is this different from iterators? An iterator is often a pool. Hey, you have the next element, has next, get me the next, has next, get me the next. You keep pulling the data in an iterator. In this case, the data gets pushed towards you rather than being pulled. It could be synchronous or asynchronous, but then how is it different from the observer pattern? Well, it's very similar to the observer pattern, except I'm going to say there are 3 channels. There is the data channel, and the data channel is where the data arrives. There is a complete channel where you know that there's no more data coming through. And by giving data through sending a signal through the complete channel, they tell you, I'm not going to send you any more data. So you can do cleanup operations. And there's an error channel. The error channel is extremely important. We have really found it hard to deal with errors in our field. It's fun to be a programmer for a while because you see all the mistakes that happen over the years. And you just sit back and you kind of look at all the errors and how we are terrible in doing things. Way back in time we said, if something goes wrong, we will return an error. Well, then we said, if you return an error, how do I get the data? Well, negative is error, positive is data. And then we realized that doesn't make any sense because data could be negative too. Okay, let's try this again. We'll return an error. If there is no error, we'll return a 0. If there is an error, we'll return an error code. Thank you very much, but where's the data now? Oh, for that you will send a parameter. We will fill the parameter and return to you. That didn't go very well. That was really hard. And one of the errors is that they forgot to fill the data. Well, okay, let's try this again. We're going to throw exceptions. That was the worst of the kind because now everyone puts an empty catch block. I mean, every week I got to tell people, please don't put empty catch blocks, right? And then this disrupt the call chain as well, not a very good way to do. And we've been sitting there and thinking, how do we deal with errors? Reactive programming says, observable says, we're going to send you error through an error channel. In other words, error is a first-class citizen. We don't treat error any differently. Error is just like any other data. So just like we're going to give you data, we're going to send error to you like data, except we're going to send it through the error channel. But when you send the data error through the error channel, then what happens? Well, imagine you have an API, and you call the API, it gives you an error. What is it that you should not do at this time? You don't immediately go back and say, here, call this again, right? I mean, if somebody says, I'm busy right now, can I talk to you later? You say, okay, can I talk to you now? I mean, that's a way to drive them crazy. But that's what we do in code, right? A code fails, we keep pinging on it, which makes it only worse. This is what we learned from circuit breakers. Circuit breakers say, if something went wrong, give it a breather, let it recover. So the minute error comes through the error channel, the data channel immediately closes up. There's not going to be any more data through the data channel because there's an error that comes through error channel. So observable has 3 channels. A data channel through which a stream of data keeps coming in, a complete channel through which one signal for complete will come. At that point, the data channel closes up. Or error channel has an error coming through, and again the data channel closes up. If that happens, that's basically how this works. So we can put these together to create applications. And I did mention that it could be synchronous or asynchronous, but one of the beautiful things about it is it allows us to postpone the time we need to worry about synchrony. Let's think about this for a minute before we get into the code. Suppose I tell you to develop an application. You go ahead and build it. You wrote it in a sequential manner. Your sequential code is in front of you. You've been working with it. Everybody is happy. One day I come to you and say, you know what? The sequential code works, but it's very slow. I want you to turn this into a multi-threaded code. That day, that moment, is when this code, which has been beautiful and lovely to look at, suddenly turns into a monster. Right? I mean, people coming to work smile at everybody. They say hi in the morning. But after that day, nobody smiles in the business, right? They walk in and they sit there and they start debugging the stupid code. Well, it becomes really hard. And so what do you tell? You've learned your lessons, right? I mean, if you open the back shirt of every programmer, you see scars. Those are called multi-threading scars, right? So you go to this developer and say, hey, dude, performance is important. What does the person do? They start with threading first. Why? Because if you start threading later, your code sucks. By starting threads in the beginning, your entire development sucks now. And you're not able to do any work at all. And as a result, you don't know what you're doing, but you got to deal with multi-threading from the day one. This has been a disaster in the making. Well, reactive programming says, oh, wait a minute, what if you can postpone the decision of concurrency to a later time? You develop the code sequentially. If the code works, and if it's performing really well, keep it sequential. There is no fun in creating threads when you don't need it. That's a Yagni principle, isn't it? You're not going to need it. I would rather develop an application and deploy it and make money out of it and produce value than saying this is a multi-threaded disaster. On the other hand, if it doesn't perform very well, let's introduce threading late in the game. Oh, but wait a minute, what if the code turns into a monster? Well, the good news is structurally, the difference between the sequential code and concurrent code is 0. That's one of the beautiful things about streams. Going from a stream to a parallel stream is incredibly simple in the syntactical manner, that is. Semantically, there are issues to deal with still. And the code structure is exactly the same. So for the first time in decades, we are beginning to see code structures of sequential and concurrent code being just about the same. And that's a huge benefit we can leverage because that means you can postpone decisions until those decisions are important. If you make decisions ahead of time, those decisions become a burden you have to carry around, and that's not fun at all in our efforts. So let's talk about how we're going to do this. This example we were talking about, how are we going to do this? So what I'm going to do here is I'm going to first of all define a little variable. I'll call it as symbols over here. And I'm interested in using these symbols to get the work done. So I'm going to say stock server.getFeed, and I'm going to pass the symbols over to it. And I'm going to ask it to give me an observable in return for me to work with. Well, obviously, I don't have a getFeed method with me right now, so I'm going to go ahead and implement that getFeed method. So what am I going to do the getFeed method? I'm going to say get me that method, and I'm going to say observable, and then this is going to be a stock info, and I'm going to create an observable of that for these given symbols. And so that is the RX observable that I'm going to get. We'll get to that point in just a minute. So I'm going to go ahead and output here created, and that's what I'm going to leave here, just to illustrate the point. But then I'm going to go back to this code right here, and I'm going to assign this over to, we'll call it feed for now. And then, of course, I'm going to say output, and then I will say over here, got observable. So that's basically what I'm going to do, is just display that and then see what happens. Well, when I go ahead and run this code this time, notice that in this case, it says created, and it says got observable. So that's pretty clear that it went ahead and called that other method that we had in the getFeed. However, I'm going to go back to this code, and I'm going to actually do some work within here. So within this, what I'll do here is, rather than returning a null, I'll say observable dot create. So I'm going to say call the create method. Well, this follows the pattern we saw in Josh Bloch's Effective Java. Rather than using a constructor, use a static factory method. That's what we are doing here. Create is a static method we're going to use. So in this case, I'm going to call an emitter, and then I'm going to simply say emit a price, and then I will send the emitter to it. Well, that, of course, requires an emit price method. So I'm going to implement the emit price method, which is a void method right now. But here, I'm going to simply say ready to emit. So that's basically the next step, a little baby step I've taken right now. If I go back to this code and run this code, well, notice that in this case, it starts up. And in this case, of course, it is going to display created, and it displays got observable. But wait a minute, it did not actually do the other method that we just saw here, which is ready to emit. It didn't do this. Oh, why is that? Well, you know the answer. It's because it's Lazy, right? Absolutely. So just like my son. So that's basically what it's doing. It's like sitting there and not doing anything. It doesn't get excited. It doesn't get really eager, right? And as a result, it says, yeah, when it's important, I'll do it, not until then. So it's just waiting, as you can see. Now, of course, we need to ask him to do some work or ask it to do some work. So how do I go about asking that? Well, let's go to the sample class right here for a second. So I'm going to say bring up the sample. OK, how do I go to the other file here? Hardy, I need your help. So what was it? Command E. He is very tricky. He reconfigured his entire keyboard for me now. So I don't even know how to use it. Thank you. So right there, we have the class here. So what am I going to do here? I'm going to say feed.subscribe. This is when you become the observer to the observable and you're ready to subscribe to it. Now, I mentioned that there are 3 channels. Well, the data channel, the error channel, and of course the complete channel. Here is the data channel. I'm going to say stock info, and then I'm going to say, in this case, an arrow, and I'm going to simply output the stock info given to me. That's the data channel. I don't have the error channel or the complete channel registered at this point, but that's OK. We can come back to it a little later. So let's go ahead and run that little bit. And, well, it's supposed to emit, but in this case, of course, I got to write the code to emit, which I haven't done yet. But you can see ready to emit being called right now. That's because we subscribed to it and said, I'm ready, give me the data, and it should supposed to start sending the data for us. So how do we go about doing that? Well, what I'm going to do now is, now that it's ready to emit, I'm going to say while true, and I will, in this case, go ahead and say the stock symbols that we are getting. So I'm going to pass the symbol right here. So this is going to be emitter, comma, symbols, where the symbols, of course, is the list of symbols that I'm going to grab from here and bring it on. So I'm going to say right there is the symbols coming in. So now what I'll do here is I'll say symbols.stream. Well, that's a good time to pause and ask the question. What's the difference between stream in Java 8 and observable in reactive programming? Because we use the word stream in a very loose, overloaded manner. And I've had developers ask me, how is the stream in Java 8 different from the stream in reactive programming? Well, conceptually, they are streams of data, something that flows towards you. That's where the similarity stops. The stream in Java 8 is a very nice, fancy iterator that's going to stream or send data towards you. It is lazy, absolutely, but it doesn't have data channel, error channel, and completed channel. It only has the data channel to send the data to you. And one thing you never play with streams in Java 8, exception handling, right? Errors are really hard to work with in streams. Reactive programming says our streams, observables, has 3 channels. The data channel, complete channel, error channel. That's very different. It has a better way to handle this. If an exception is thrown in a reactive observable, it grabs that exception and then sends it as a data, an error, through the error channel. So exceptions are perfectly normal and OK to deal with in reactive programming. One of the reasons for that is in the model of imperative style of programming, we deal with exceptions by blowing up the stack and going back to where we came from. That doesn't make sense in a stream because a stream is like driving a car on a freeway. If you have a flat tire, the most illogical thing to do is to reverse back, right? That's kind of exception handling, right? You never do that, right? If a car has a flat tire, you exit safely or go to the shoulder safely. That's the whole idea. You always move forward. You don't go backwards. So reactive stream says, we're going to take this exception and push it down as an error so you can deal with the downstream. So that's the difference between those two. So now what am I going to do? I'm going to then say over here, map, and then I'll say stock info, and then in this case, info : fetch. What in the world is the fetch method? A fetch method simply goes out to Yahoo Finance and gets the stock price for us and bundles it into a stock info and returns it. And you may say, what does get price do? It gets the price raw data and parses it. I've learned that showing the code for parsing in public is not a good manners. So I will not show this to you here, but in the privacy at home or office, you can take a look at it. Make sure there are no children near you. You don't want them to be seeing parsing code. Okay, so now that we have seen this one, let's go back and see how this is going to work. Did I say Control E again, Hardy? Command E, all right. You didn't reconfigure it while I was doing this, or did you? All right, so let's try this again. So what am I going to do? I'm going to go back to this one here and say, all right, I have this right here. We did a mapping of the symbol to the stock price for each, and I'm going to say emitter on next. This is our data channel through which I'm going to send the data. Then I'm going to just take a break, sleep for a second, if you will, where the sleep, of course, is a method I'm going to create right here. So public static, let's say void sleep. This is going to take in milliseconds, and then I'm going to say thread dot sleep, and then, of course, this is going to be that many milliseconds. And, of course, it tells me you've got to handle the exception. But as Java programmers, we know exactly how to take care of it. That's wonderful, right? So that's taken care of. So that's basically the idea. We got this being generated right here. So now that we are doing this, let's go back and try this again and run this. So what does this really do? Well, we can see that it starts emitting the data. And our friend Powell can confirm if that's the right data. And so that's basically where it's pulling the data and displaying it. So we just saw how that is coming through in this case. So, all right, so we saw how to bring the data. But what if that is a sequential code, as we know, that is doing the job right here? Okay, but there are times when we want to control the interaction as well. Imagine you have a service that's going to be sending data to you. Well, I'm using, pardon me. In Java, there are several implementations of this. Just to kind of go back to the background again, the concept of reactive programming was introduced by Eric Meyer as part of his work in Microsoft research. I'm good friends with people who are using Microsoft technology. I program in .NET as much as I program in Java, as much as in JavaScript. I like to program in all these languages. And, but one of the things I've noticed with people programming in .NET is the .NET programmers are the sweetest people on earth. You give them a solution, they'll quietly go produce a result and make money out of it. But the Java people and JavaScript people are very different. You show them a solution, they will run out and create 50,000 frameworks around it. And so this idea has been around for a long time in the .NET world, but nobody really knew about it. And then the Java people and JavaScript people looked at this and said, this is awesome. And they started creating so many solutions. One such solution is RxJava. Apparently, Netflix has some problems with the streaming they have to deal with. So they open source their solution, but there are so many other solutions. You heard a few today in other talks, and there are other solutions out there as well. But RxJava is just one solution, which is really a nice solution. That's what I'm using here. And in this case, of course, I'm using RxJava. But the point, though, is, imagine you are Netflix, for example, and somebody comes to you and says, I want to know a list of all the movies available. Well, you're listing all the movies, but of course, you're not going to give them all the movie details at once. You give them a bunch of movies for them to look at. And I'm parsing it through. It's like, okay, I've seen that movie, and I'm making this very critical decision. Do I want to watch this movie for the 20th time, or do I want to look at more movies in the list? When my good friend calls and says, would you like to go out? I'm like, thank you for calling. And I'm going to leave, but obviously, you don't want Netflix to be holding on to resources when I'm gone. That's not a good use of resource. That's not going to make it scalable or other things. So I want to be able to tell Netflix or any other service, thank you, but no thanks, I don't want any more data. On the same token, suppose you are listening to a device or a flight that's in flight, and the flight lands or the device is going to be shut down. It would be nice to be told that there's no more data coming towards you, so you can do the cleanup. So there's got to be a two-way communication to do that. So in order to illustrate that, let's go back here and see what we could do. I'm going to go back to the getFeed method, and in here, I'm going to make a small change here. I'm going to start with a count, just as an example here. I'm going to say count is equal to 0, and I'm going to say while count is less than, let's say, 5, I want to do this work, and then, of course, I'm going to increment the count right at the end of this. But when I come out of this, I'm going to go ahead and say, well, just for our purpose for now, let's see this, emit.onNext, and I'm going to say new stock info, blah, and then 0.0, just so that we can actually see this come out at the moment. So in this case, of course, if I go back here and run this little code, what you're going to notice at this point is that you can see that it's running through that many times, but at the end, it's going to say the blah and 0.0 because that's the data that comes through the data channel. There we go. But instead, what I'll do here is I'll go to the end of this and say, right at this point, right before this, I'll say emitter dot on complete. And I'm saying, that's it, I don't have any more data for you. Remember what we talked about earlier. The minute complete channel sends a signal, the data channel closes up, which means that line 30 should not send anything to the observer. Well, let's see if that's actually true. So if I go back to the sample and run this, you will notice that in this case, it produces the result as we saw before, but when it's completed, you would not see the block come out at this point because the data channel was terminated. But on the same token, what I can do here is I could now say, well, let's ignore the error for now. Let's not worry about it. So I'm going to simply say system.out and then println for now. And then I'm going to then say over here, the complete channel, I'll output done, and that way we can take a look at the output signal. So when the observable sends the complete signal, we can get the data here on the other side, what they've done. So this becomes the data channel, this becomes the error channel I mentioned earlier, and that becomes your complete channel, and you got these 3 channels coming from the observable. But what's really cool about this is you can communicate from the observable down to the observer that you don't have any more data. On the same token, you can also communicate from the observer to the observable that you don't want any more data by unsubscribing your subscription. And for that, you would call a method from here and say unsubscribe, or in this case, dispose, and then it would dispose the resource and say, I'm not going to send you any more data. But what's one of the really cool things about this kind of approach is you could also deal with errors very nicely. So how does error handling work in this context? But before I talk about error handling, I want to emphasize one thing which is absolutely cool. And that is, right in the middle of this, you know that feed is an observable. You know that you have an observer at your hand over here. But between the observable on one end and the observer on the other end, you can put intermediaries. These intermediaries would become observers to the upstream observable and become observable to downstream observers. So I could be the observer of what's coming up here, and I could be the observable of what's down here, and this can be extremely effective. So what I can do is I can start filtering data. For example, if you notice the prices of Google and Amazon and Intel right now, but what I can do here is I can go to this code and say .filter, and then I could say given a stock info, and then I can say if the stock info value is greater than 500, then send it down, not otherwise. So if I were to go back and run this code, you would notice that you're getting only the price of Google and Amazon. You no longer are getting the price of Intel because you filtered out. This is like what we heard this morning. They were saying we get a lot of data, but we don't care about most of the data, right? We only care about a small part of the data. You could filter out and say, this is the area where we are interested. Don't keep all this noise, avoid it. Only send me what's important, right? It's like me. I would sit in a crowded place, I'll be coding. I would not hear anything at all until they mention the word food. I'm like, what? So it's a beautiful filter in the ears, right? So you can just filter things out, and you can work with this really nicely. So that is one of the nice things. But you can also go a step further, and you can say, do a map for me. And I can say stock info, new stock info, and then I can say stock info.ticker, comma stock info.value times 0.9, I can give myself a little nice discount on the price for purchasing, right? We can do some internal trading if you want to. So we could see that it can be reduction in price as well that we can get. So you can do all these kinds of nice transformations. But that still begs the question, what do we do if things were to go wrong? Well, that's Murphy's law. What do you do if things goes wrong? How do you handle that? Well, in my case, my computer went wrong, and I sought help from Hardy. That was really good. But what about a stream? What do we do about it? Well, there are two things you can do about it. The first is if something were to go wrong, and it might, we want to be able to handle that. So if I go back to this fetch method that we have here, notice that in the fetch, at some absolute random time, I'm going to blow up. So I'm going to say, oops, ran into trouble, right? I mean, messages like this are wonderful because it gives nobody any clue what just happened, right? So that's kind of in line with what we normally do. So it just blows up saying, oh, I ran into trouble, something is wrong. But what am I going to do when something were to go wrong? Well, I'm going to go to the stock server, and I'm not doing anything here, as you can see. I didn't touch it at all. I'm not doing any work. I could. Definitely, it's a good thing to deal with it. But I'm not doing anything with it. But if I go back to the stock sample that I was working with, notice that I have an error channel right here. But just to make it absolutely clear, I'm going to say error, and then I'll output and say, error in all uppercase, and then I'll just print the error. So, or I could do other things, of course, right? To handle the error, do whatever it is, play a sad music, tell the user, whatever I have to do. But now when I go back and run this code, you can notice, in this case, it starts up, does it? So it's going to start up and start running through this. And then, of course, you can see that it ran into error right away. It runs into error when you don't want it to. Just stay a little longer. OK, it gave us one prize and it failed. So when it fails, though, notice the error up here. What does that show us? It shows us that it took the exception, but quietly sent the exception as an error through the error channel. This is something very important to keep in mind because when you typically work with a multi-threaded application, when you have multiple threads running, when some thread randomly fails, what happens? Good luck, right? It's extremely hard to deal with it. And imagine you have 1,000 threads running, and all of a sudden, 179 threads failed. What do you do in that situation? If you want to get a glimpse of how that feels, imagine you're running a daycare center, you have a lot of children, and all of them start crying exactly at the same time. How would you feel? That's how it feels when you code these applications, right? It's completely out of control. This says, no, I'm not going to throw exceptions at you. It is very civil, right? It's not throwing things at you. It's handing over the error and says, here you go, here's the error, and it gives you through the data channel, and that's what you're getting here. Of course, I could have done a try and catch in the code, and I would have said on error, and I would have sent it. Let's take a look at how I could do that. So I could go back here, and I could simply do a couple of things. I can say, well, at some point, if I run into an error. So for instance, if, just as an example here, if, let's say, count is greater than, let's say, 2, I could then say emitter.onError, and then I could send a throwable, new runtime exception, oops. So this is a throwable I'm sending. Notice I'm not throwing a throwable. I'm just handing over a throwable to it and say, please go handle this. And as a result, what's going to happen here is it is going to get that exception on this side. If and when things were to go wrong, we're going to get that exception here to deal with. So that is one thing that you can do very nicely here in terms of how you want to deal with it. And right there is the oops coming through. Oh, wait a minute. So that's where the oops is going to come through, and we get the error through the error channel. Well, right there it came through, and you better handle this on this side too. So that is basically the error. I shouldn't have sent it in a loop again, but anyways, that's a separate issue to deal with. Okay, so, but one other problem to think about. What happens when there is an error? Well, the minute there is an error, you're no longer going to get the data because the data channel closes up, which is a good thing in a lot of situations, but not all the time. There are times when a service fails, you may have to switch over to another service. For example, let's say I'm leaving in the morning and the map doesn't work. I don't want to call my boss and say, I'm not coming to work because the map doesn't work. That's a good excuse to give. And they would say, why don't you use some other map or just ask for directions? Well, the point is you want to switch over. Well, one of the things you can do here is when such need is there, you can say on error, resume next, and you can provide a backup service to switch over. But the beauty is, notice where we insert this right in the middle. So I become the intermediary again. As the data is flowing through, I'll keep sending it. But if the source fails, I will take care of the failure and start generating the data new. And this becomes a very effective way to do it. A couple of other small details I want to mention really quickly. This is somewhat specific to RX Java. I've been using Observable here, but RX Java also has what are called flow. When do you use one or the other? But in other solutions, you don't have the distinction, but the key idea here is what's called the back pressure. The idea behind back pressure is observables don't deal with back pressure, flow do. This is again specific to RX Java. But back pressure is a generally important concept to think about. If the source is sending me data at a rate faster than I can handle, what am I going to do? This is where the back pressure comes in. I can tell it, why don't you just buffer those, and then I will pick it up and run with it. Buffering makes sense when you have times of slowness and regular speed, and you have an ability to catch up with it. If you're always going to be slow, it doesn't make sense to use back pressure because it's going to fill up. There are also applications where you may want to drop in the case when things are beginning to slow down, only because you don't care about all the data, you care about the latest data. But the point really is, it really comes down to the nature of your application. Whether you want to buffer when you have do you want to buffer the data or do you want to drop it? There are also solutions for throttling the data, debouncing the data. If the data is coming at a very fast fluctuation rate, what do you do with it? Imagine, for example, you want to deal with a user's typing. So when I start typing, what happens? My wife says that I am one of the best people she knows who can type extremely well the backspaces. So I keep editing and editing, right? So you type something and you hit the backspace, you repeat it. Well, you don't want to be working at that speed because it's a lot of noise. So you could say, you know what, throttle, let this guy stabilize what he's typing, and then when he has fixed all his errors, I'll take the data and work with it. That can be very powerful too, and you can use that as well. There's a lot of other things built on top of this to make this really useful. But to summarize what we talked about, the whole idea behind this is, think of deviation from CRUD. We're going to still do CRUD applications, but not everything we do has to be a CRUD application. There are times when, quite a number of times when, we want to be able to deal with data where the data is a stream of data that flows towards us. We want to be that intermediary to take actions if the data is interesting and then transform the data and pass it down for something else to potentially handle that. And so this is becoming very popular. There are two reasons why we want to really take the time to learn it. One reason we want to learn it is maybe we want to build a reactive application. That's a good goal, but I'm a little bit fearful of those goals also because I'm not a big fan of just using a technology because it's out there. My business needs to really have a good use for it. So until that point, of course, you're learning, but you may not have a good reason to use it until you see that use. Well, if I don't have an immediate use for it in my application, should I learn this? And the answer is yes. And the reason is a lot of libraries that we use are beginning to go reactive themselves. So even though you may not build a reactive application immediately today, the application libraries you are using are going to give you reactive solutions. For example, if you're programming in Angular 2, by default, the HTTP module is returning an observable to you. You can throw a promise on it and use it too, but if you are familiar with observables, it puts you at a better spot because, hey, I know what this stuff is. I can make a conscious, informed decision whether I want to continue using observable in this API or I want to convert it to promise and use it, but that would be a clear, good decision you make knowing it. That's another reason for you to really look at. I hope that was useful. Thank you for your time.